Well, welcome back. I promised you the quotient rule, and here is doing the derivative of the quotient rule. This looks a little uglier, but it's not that difficult. So if I have a quotient of two functions, right here, u over v, I can take the first function, v, or the denominator, multiply the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So I like to make things a little bit simpler. So I have f prime times g of x minus f g prime of x all over g of x squared. So in short, if I have a function y equals f over g, alright, I can say here's what it is, f prime g minus f g prime over g squared. So the difference here is the minus sign, because we're used to the plus with the product rule. And I've seen it also taught this way, where they call this one high and this one low. So they say that they call it this one. They say low d high, the derivative of the high, minus high d low all over low squared. So it's low d high minus high d low over low squared. I just memorized that f prime g minus f g prime over g squared. So the derivative of a quotient is the derivative of the numerator multiplied by the denominator minus the numerator multiplied the derivative of the denominator all over the denominator squared. Okay? So this is set up the same way. We're going to still set up our work like I showed you before, but these are all going to be quotients. I'm going to do a few problems with you and then we'll practice more in class. So this one is going to be right here, f, and we'll call the low g. So let's set it up. So I have f equals 4x, f prime is 4, g is x squared plus 1, g prime equals 2x. So let's set up our new thing. F prime is going to be f prime g minus f g prime all over g squared. So f prime of x is going to be f prime times g, so it's 4 times x squared plus 1. Now the difference with the quotient rule is I like to, after the minus sign, put a bracket so that it makes it a little bit easier to do the algebra. And then it's f g prime, so I have 4x times 2x all over g squared, which is x squared plus 1 squared. So now I have f prime of x is, and we're going to multiply the first part here. And another way I like to do this too, because I like this in factored form and you try to factor as best as possible, is I'm going to look and factor out what I can out of both of these, and I can take a 4 out of both of those. When I do, I end up with x squared plus 1 out of the first term minus a 2x squared out of the second term, because if I take that 4 out, what's left is 2x squared, or divide it out, all over x squared plus 1 squared. Now let's look at how we can make this look a little nicer. And so this is going to be 4 times a negative x squared plus 1 all over x squared plus 1 squared. So I wouldn't ever multiply the denominator out. Don't do that, because if you can factor something, leave it in factored form. Alright, let's look at the second one. I have an f and I have a g. So f is going to be x squared minus 4. F prime is going to be 2x. Alright. G is 2 radical x. And I'm going to think of that as x to the half when I do the derivative. So g prime is going to be a half times 2, okay? So that's going to be a 1, x to the negative a half. So f prime is going to be f prime g minus f g prime all over g squared. So f prime of x is going to be f prime times g. So I have 2x times 2x to the half. I'm going to write it that form. Minus, I always like a bracket, okay, f g prime. So I've got x to the negative half. I'm just going to put it in front, times x squared minus 4. Okay, all over g squared. Please don't forget that, because A lot of times I'll have kids do this perfect and forget the denominator. Okay, now when we go to combine these, I want you to remember your exponent rules. So let's look at it. I have 2 times 2 is 4. This is x to the first, but if I add my exponents, that's going to be 2 halves plus 1 half. That's x to the 3 halves. Minus, now we're going to multiply it through. So let me go back to where I was. Multiply it through. So I do this. So I have x, and if I add those, I'm going to add again. I'm going to have another x to the 3 halves. Okay, plus, because this is negative, 4x to the negative a half. Right? All over. Now if I square the bottom, I've got to square the 2, and if I raise that, a half raised to the 2 is x to the first power. So now I have f prime of x is going to equal, now I see how I can combine these two. Do you see that right here? So I have 3x to the 3 halves. Okay, plus 4x to the negative a half all over 4x. And you're like, what else can I do to this? Well, there's more you can do, because when you go to factor, I can factor some out. All right, so if I factor out of this, I can take out of these two terms. So this is a term, think of it this way, this is a term and this is a term. If I take out my lowest exponent, it's going to be x to the negative a half. So if I take out x to the negative half out of the first one, you're really subtracting. So 3 halves minus a negative 1 half is actually adding. So that comes out to be, when I do that, a 3, and the x, it turns to an x squared, okay, plus 4, because if I factored out, all over 4x. Now this x to the negative half can go down, so I have f prime of x is going to be 3x squared plus 4 all over 4x to the 3 halves. I think the exponents will cause you the most problems, so it's good practice. Let's try a couple more. Okay. So I have another quotient here. So you can shut the video off and try it yourself and then come back. That would be good practice. So here's f and here's g. So f is going to be, I'm going to write it like this, x to the 1 half minus 1. F prime is going to be a half x to the negative a half. G is going to be x cubed. G prime is going to be 3x squared. Okay? So let's go. F prime is f prime g minus f g prime all over g squared. F prime of x now is f prime g. So I'm going to, when I put this in here, f prime times g, all right, minus, I always like a bracket, f g prime. So I'm going to put the g prime first, times x to the half. Let's erase that. Minus 1. All over g squared. Okay, now it's simplifying it. F prime of x. Now when I multiply these two, you add the exponents. So I'm going to have x, a half, and then this is 6 halves minus 1, so that's 5 halves. Minus, then I'm going to multiply this through. So that's going to be 3x to the 2 halves plus 1 is 3 halves. No, it's 5 halves, excuse me. It's 4 halves plus 1 half. Minus, excuse me, plus 3x squared all over x to the 6. So I have f prime of x. If I combine these two up here, I see how they combine. So I have a half minus 3. So this is 6 halves, negative plus a half, so it's negative 5 halves. X to the 5 halves. Okay. All right. Plus 3x squared all over x to the 6. Now, I look at it, these, I can divide both of those by x to the 6. So f prime of x is going to be negative 5 halves. And if I'm subtracting this, this would be 12 halves. So that's x to the negative 7 halves. plus, now they can be, these two can be divided. So just remember, you're basically splitting it up. I can divide these two and then these two, and I do them separate. So that's how I got the first one. This one is going to be a 2 minus 6 or negative 4, so that'll be a little bit easier math. And there is your final. So you'll see a lot of this is just practicing with exponents and playing with algebra. Okay? One more time. F is 4. F prime is going to be 0. So this is my F and G. G is, okay, 3 plus radical x, and we can call that x to the half. G prime is going to be 1/2 x to the negative 1/2, because the derivative of 3 is 0. Okay? So f prime of x is going to be f prime g. Now if you'll notice, if I do f prime times g, that's 0, just so it doesn't even show up. So we only have the second part, minus f g prime. So I've got 4 times 1/2 x to the negative 1/2 all over g squared, which is 3 plus x to the half squared. Okay? So f prime of x here is going to be negative 2 x to the negative 1/2 all over 3 plus x to the half squared. And I can bring this x to the negative 1/2 right down in the denominator now. So I have f prime of x equals negative 2 all over radical x times 3 plus radical x squared. Okay? So these two videos conclude our F and G's, that I call it, that we're doing for the product and the quotient rule. The next video will be on applications.